Hello, in this screencast, I will show you how to work with Play's build files. Play uses SBT build tool for both Scala and Java projects. Let's create a sample Play project using Activator template. In this case, I'm using Hello Play Framework Activator template. I've already downloaded the project and started Activator console. The first thing we're going to do is take a look at the build.sbt file, which resides under the root folder. This is a build file for Play projects. Unlike other build tools that uses XML, SBT uses simple DSL to define build. Here, each line is a build expression. In SBT terms, they are called settings. Here, the name is the settings that configures the name of the project. The version number defines the version number of the project. The library dependency defines all the third-party libraries that this project depends on. Play Java settings provides all the Play-specific build configuration. Let's add a popular third-party library called JodaTime to this project. The first part of the string is the name of the group ID of the dependency, separated by this %. Then comes the artifact ID, and finally the version number. This is quite similar to how you specify dependencies in other build tools, only the syntax is a little different. Now let's see this dependency in action. I already have a controller called application.java. Inside this controller, I have this now action that uses this JodaTime dependencies. Let's uncomment this lines. Save the change. Now let's see whether this endpoint works. That endpoint is supposed to return the current date and time. The Play application is running on localhost 9000. I will hit the endpoint now. Now Activator is loading the project and we have this endpoint working. The next thing I'm going to show you is how to extend Play's build system. SBT build tool has a very nice and simple plugin architecture. Using SBT plugins, you can add new features to the build system. For example, SBT by default knows how to run your test. This project does have a couple of tests already, but it doesn't know how to generate code coverage report. Let's add a new code coverage plugin to this project so that we can generate some coverage report. To add the plugin, we will edit the plugins.sbt file under the project folder. The name of the plugin that we're going to use here is Jacoco Code Coverage plugin. I will add the plugin now. This plugin exposes settings and tasks that we can use to generate coverage report. Now let's add all the settings to our build file. This is the plugin settings. This information is available in respected plugin project site. Now let's invoke this coverage report. To do that, I'm going to open a command line prompt and use Activator to execute my coverage task, which is under Jacoco cover. This will load the project definition and execute my test. Now that all the tests ran successfully, let's look at the coverage report. Which is available under the target folder. HTML and index.html. There is a coverage report that generated for this project. The last thing I want to show you is how to work with multiple Play projects. It is very common to break large Play projects into multiple smaller modules. This improves the code organization and maintainability. I have already added two smaller Play projects under modules folder. Both backend and front end are independent Play projects. I have seen in the real world large Play projects broken down into 10 or 15 modules. In this example, I will show you a very common pattern. Here, we'll make our root project an aggregator for both backend and front-end Play projects. Typically, this root project or aggregator project will not have any application logic. It will just aggregate other projects and provide application properties like we have here application.conf. Each individual Play project under modules will have their own build file and build settings, and will also have its own routes file. Now what we're going to do is that take all the routes file, import them inside the main route file, and define all this project inside the build.svd. First thing we're going to do is that let's take a look at the routes file and import the backend and front-end routes. I've already done that here. I'm just going to uncomment these two lines. This arrow syntax imports other route files or include other routes file. Now let's see how we can define these projects in our build. First thing I'm going to do is that create a build expression, create a project expression for my backend project. Use the project helper and specify the location. In this case, it will be modules/backend. Similarly, we'll have one for the front end. And finally, an aggregate project. Let's call that project main. This aggregate project points to the current location, which is a current folder, and depends on both backend and front-end project. It also aggregates on both backend and front-end project. The benefit of aggregate is if I run a task on main project, it will automatically run tasks on my module and submodule projects. Let's save these changes and restart our application. Now that our application is running, let's test each endpoint. First thing I'm going to do is that invoke the index action of my aggregate project or min project. And now I'm going to run index action of my backend project. Says I'm inside backend project. And let's also test the front end project. So without much hassle, we were able to work with Play's build system. And in short amount of time, we learned how to do some basic common stuff. To learn more, please check out all the available activator templates and Play documentation. Thank you.